Hello students, in today's lecture we are going to derive the relationship between the differential cross sections in the lay frame and center of mass frame. It must be noted that the number of particles scattered into an infinitesimal cross section d sigma in the direction of theta phi in both the frames is same. That means that the differential cross section is independent of the lab or CM frame. It doesn't depend on the frame. That means that in both the reference frame the number of scattered particles in the direction of theta and phi are the same. It means that the number of particles scattered in the direction of theta and phi through an infinitesimal cross section in the lay frame and in the CM frame both are the same. The only difference in both the frame is the solid angle. The only difference is the solid angle. That is, the solid angle in the lay frame that we represent by d omega 1 is actually the sine theta 1 d theta 1 d phi 1. This is the solid angle in lay frame, and in the CM frame is d omega, which is sine of theta, d theta and d phi, which is in the CM frame. So these two quantities only differs, and the number of particles scattered in the direction of theta phi and in the both frames are the same. Thus, let's suppose this is equation number 1. Now, multiplying this equation 1, we can write this equation as d sigma, which is a function of theta and phi. I can divide it by d omega 1 and I can multiply it by d omega 1, so there is no difference. This is for the lay frame, and the right hand side can be written as d omega d sigma upon d omega in the CM frame. It can be written as in this form. Or I can also write this equation as, we don't need to write any more theta 1 and phi 1. We have only two. Remember that this is the lay frame and this one is the CM frame. So d sigma upon d omega 1 in the lay frame can be equal to d sigma upon d omega in the CM frame, and this will be d omega upon d omega 1. So bringing this d omega 1 to the right side of the equation. and further this we know that in the CM frame d omega is actually this one, which we already written as. So this can be written as d sigma upon d omega 1 in the left frame, which is equal to d sigma upon d omega, which is the number of particles scattered into a solid angle in the direction of theta phi cm, and d omega is sine of theta d theta d phi upon sine of theta 1 d theta 1 d phi 1. This is, let's suppose, equation number 2, where theta 1 and phi 1 are the scattering angles of the incident particles in the left frame, where this angle theta 1 and phi 1, these two angles are the scattering angles of the incident particle in the left frame, while theta and phi are the scattering angles of the incident particle in the CM frame. Since due to the cylindrical symmetry of the incident beam, you know that the incident beam was a cylindrical, has a cylindrical symmetry. So due to, it must be noted that due to cylindrical symmetry of incident beam, these two angles, which is phi is equal to phi 1, these two angles are the same in both the frames. Thus, if these two angles are the same, then we can cancel it. Therefore this will be equal to d sigma upon d omega 1 in the left frame, which is d sigma upon d omega in the CM frame, sine of theta into d theta upon sine of theta 1 d theta 1. And further we know that actually the differential of cos is, if we differentiate cos with respect to theta, so this is minus sine of theta, clear, and if I bring this d theta to the right, this will be d cos theta is equal to minus sine of theta d theta. And similarly, if I in the similar way d cos and d cos theta 1 can be equal to minus sine of theta 1 d theta 1. So the negative sign cancels in the numerator and denominator, therefore there is no need to write the signs, it doesn't depend on the sign. So sine theta d theta is actually equal to d cos theta, and sine theta 1 d theta 1 is equal to d cos theta 1. Therefore we can write this expression as d sigma upon d omega 1 is equal to d sigma upon d omega, and this will be d cos of theta, and in the denominator this term is d cos of theta 1. This is equation number 3. Now this is the equation, and now we have to find this parameter, which is d cos theta upon d cos theta 1, and then we have substitute that parameter. In the previous lecture, which was the relation between the angles in the lab frame and the CM frame, we find the relation for cos theta 1, which was this equation. This equation was derived in our previous video. This was the relation between the angles in the lab frame and in the CM frame. This is the angle in the CM frame, which is theta, and this is the angle in the lab frame. So it was the topic, the connection between the angles in the lab frame and in the CM frame. Therefore, we have this expression, and now I can write d cos theta 1, and cos theta 1 is this one, divided by d cos theta. This means that differentiating cos theta 1, differentiating this expression with respect to cos theta. Remember, this expression, this value has a meaning, differentiating this equation with respect to cos theta. Remember, cos theta 1 and theta are not the same, they are different. This is the angle of the incident particle, in the lab frame, and this is the angle of the incident particle in the CM frame, and they are not the same. So I can write this expression as d upon d cos theta, and cos theta 1, which is cos theta plus m1 upon m2 divided by whole under the root 1 plus m1 square upon m2 square plus 2 m1 upon m2 cos theta. Now differentiating this expression with respect to d cos theta. So using the quotient rule, this is, if you have forgotten, this is the rule, which is d upon dx of f of x upon g of x. This is equal to g of x into f prime of x minus f of x g prime of x upon g of x square. Okay, this is the rule, and using this rule we have to differentiate this equation. Now d cos theta 1 upon d cos theta, this can be written as, this is equal to, which is, this one is, in this expression, this is g of x and this one is f of x. So g of x is 1 plus m1 square upon m2 square plus 2 m1 upon m2 cos theta under the root into derivative of this one. So differentiating this cos theta plus m1 upon m2 with respect to cos theta, so the derivative of this term will be 1 plus derivative of this term is 0 because this is constant, this is 0 minus f of x, which is cos theta plus m1 upon m2 into derivative of this one, which is the derivative will be 1 over 2. Let me write it below here. 1 upon 2 into 1 plus m1 square upon m2 square plus 2 m1 upon m2 cos theta, and this will be 1 over 2 minus 1, so it will be minus 1 over 2, and internal derivative will be, this is constant, and here it will be 2. These are constant with respect to theta, so the derivative of this term will also be equal to 2 m1 upon m2, and derivative of cos theta is 1. Clear? Divided by 1 plus m1 square upon m2 square plus 2 m1 upon m2 cos theta under the root whole square, using this rule. Now if you see here, this square and this under root will be cancelled with each other, and this equation will be simplified as this is under the root 1 plus m1 square upon m2 square plus 2 m1 upon m2 cos theta minus this is 1 upon 2, this 2 and this 2 will be cancelled. Clear? And m1 upon m2 is in multiplication with this term, so this negative sign will be written here. This is m1 upon m2 into m1 upon m2 plus cos theta, and I can write this term in the denominator to this one, because here the power is minus 1 over 2, so bringing it to the denominator it will be 1 plus m1 square upon m2 square plus 2 m1 upon m2 cos theta, and it will be plus 1 over 2 or under the root, divided by this term, which is 1 plus m1 square upon m2 square plus 2 m1 upon m2 cos theta. Now further simplifying it, only the numerator term, taking the LCM, so by simplification it will become like this one, which is 1 plus m1 square upon m2 square plus 2 m1 upon m2 cos theta multiplied by this term, which is here the power is 1 upon 2. multiplied by this one, which is 1 plus m1 square upon m2 square plus 2 m1 upon m2 cos theta minus m1 upon m2. When these are multiplied, so it will be m1 square upon m2 square minus m1 upon m2 cos theta divided by 1 plus m1 square upon m2 square plus 2 m1 upon m2 cos theta. Here we have forgotten this. Here it has an under the root. Clear? Over this term it has under the root. Clear? So when these two terms are multiplied, so it will become 1 plus m1 square upon m2 square plus 2 m1 upon m2 cos theta minus m1 square upon m2 square minus m1 upon m2 cos theta, and in the denominator we have 1 plus m1 square upon m2 square plus 2 m1 upon m2 cos theta. So this negative m1 square divided by m2 square will be cancelled with this one, and here we have 2 m1 upon m2 cos theta, and here is negative m1 upon m2 cos theta. So we will be left with only 1 plus m1 upon m2 cos theta divided by 1 plus m1 square divided by m2 square plus 2 m1 upon m2 cos theta. Remember, this is the value of d cos theta 1 upon d cos theta. So this is the one thing is which I have forgotten here in this step. Look at this step. Here we have 1 plus m1 square upon m2 square plus 2 m1 upon m2 cos theta, and similarly we have this term as well. So when this one is multiplied with this term, so the whole power will be raised to 1 plus 1 over 2. This is 1 plus 1 over 2. If we bring this term, first taking the LCM of these two, it is multiplied with this term. Clear? And subtraction, we have this one, and after in product it will be multiplied with this term, so it will be 1 plus 1 over 2. So this is easy, but I have forgotten here. So here the value will be 3 upon 2. 3 upon 2. So this is the final result, and now we can substitute it. We can substitute it here in this equation 3. But remember, we have here the parameter was d cos theta upon d cos theta 1, and we have find d cos theta 1 upon d cos theta. So we should put its reciprocal in equation 3. This is equation number 4. Therefore equation number 3 will become, which is d sigma upon d omega 1 in the left frame, which is equal to d sigma upon d omega in the CM frame, and the reciprocal of this will be 1 plus m1 square upon m2 square plus 2 m1 upon m2 cos theta whole to the power 3 upon 2 divided by 1 plus m1 upon m2 cos theta. So this is now equation number 5. This was equation 4 and now we have equation number 5. So this is the connection between the differential cross section in the left frame and in the same frame. And in the similar way, actually this was the scattering differential cross section for the incident particle, which was m1 in the left frame. This was for the connection of left frame and in the CM frame. Similarly, for the target scattered particle, if we have here we have a target particle, this was the incident, its mass is m1 and its mass is m2. So when it strikes the target particle, the incident particle scatters in this direction and the target particle also goes in this direction with an angle theta 2. Its angle was theta 1 and its angle is theta 2 in the left frame. So if we are going to find the relation for the scattered target particle, which is m2, therefore we can write it as d. Similarly, for the target scattered particle m2, so for that we will have d sigma upon d omega 2. So this was for the first particle, the incident particle, and this will be for the target scattered particle in the left frame, and it will be equal to d sigma upon d omega in the CM frame. And by similar way we will have sine of theta d theta divided by sine of theta 2 d theta 2. Clear? And d phi is cancelled with the d phi. Therefore, by simplification, we can write it as d sigma upon d omega in the CM frame. This is d cos of theta, and this can be written as d cos of theta 2. And theta 2, cos theta 2 was in the previous lecture, which we found that it was phi minus theta upon 2. It was related with also with theta. So by using that expression here, we can find the result, which is 4 sine of theta, for sine of theta upon 2 into d sigma upon d omega 2 in the CM frame. So this is the d sigma upon d omega 2 in the left frame. So this will be the result for the target scatter particle. This equation 5 is the relation between the differential cross section in the CM frame and in the left frame for the incident particle, and this equation 6 is used to find the relation between the differential cross section in the left frame and in the CM frame for the scattered target particle M2. So here we are having some limiting cases. Remember, the first case is if m1 is much greater than m2. M2 is much greater than m1. That means that the target particle is very heavier as compared to the incident particle. Clear? Then in this expression, look at here, this term and this term will be neglected. They will almost equal to 0. Similarly this one, and in the denominator this one. So then the lab frame and the CM frame results will be the same. Then this means that then lab and CM frames results will be the same. That is d sigma upon d omega 1 will be equal to, in the lab frame, will be equal to d sigma upon d omega in the CM frame. So these two results will be equal. And if the second case, if m2 is equal to m1, then in the previous lecture, which is the tan theta 2, this expression, this will be equal to, then tan theta 2 will be equal to tan theta 1 will be equal to tan theta upon 2, or theta 1 will be equal to theta upon 2, and from this equation, d sigma upon d omega 1 in the lab frame, this will be equal to 4 times d sigma upon d omega cos theta upon 2. So these will be the results. Thank you very much.